58 months.
That's how long it takes right now to order and receive a high-voltage transformer for an AI data center. 5 years. It doesn't matter how much you pay. It doesn't matter who you are. It doesn't matter what earnings call you go on to announce the project.
Every press release you've read this year about AI infrastructure, every gigawatt commitment, every breaking ground photo, assumes that number doesn't exist.
Let me back up. If you've been paying attention to AI for the last 2 years, you know the shape of the story. Hyperscalers, Microsoft, Meta, Google, Amazon, are committing something north of $600 billion in capital expenditure. Data centers are going up. In Wisconsin, in Louisiana, in Arizona, in Ohio, every state's economic development office has a pitch deck. The future is here. It's electric. It's compute. And the only real question is how fast.
That's what the earnings calls say. That's what the financial press says. That's what the podcasts say.
And for about 2 years, that's what I believed too. Because I was reading it through the only frame anybody was giving me. CapEx versus revenue. Valuation multiples. Concentration risk. Bubble or not bubble. A market question. It wasn't a market question.
Somewhere in Varennes, Quebec, a factory floor is assembling a transformer.
It weighs over 500 tons. It has miles of copper wound by hand inside it. The copper was being wound 18 months before the factory's shipping door had even been ordered. The bushings, the long porcelain columns that keep the high-voltage connections from arcing to ground, required 18 months of dielectric curing before they could be installed. The core is made from individual steel sheets, stacked one at a time, like a very slow Jenga game. When this transformer is finished, and it won't be finished until sometime in 2030, it will be loaded onto a rail car that was custom built to carry it, driven to a substation whose ground hasn't been broken yet, and installed at an AI data center whose groundbreaking photo hasn't been taken. The data center that this transformer belongs to was announced in 2025, and the AI chips that were supposed to go inside the building next to it, the chips that justified every line of every press release you've ever read about that site, by the time the transformer arrives, those chips will be a generation and a half obsolete.
The obsolescence is predictable.
This is what the AI build-out actually looks like when you stop reading about it in dollars and start reading about it in objects. Half of the US data centers announced for 2026 have already been quietly delayed or canceled. Not because the money stopped, because the machines didn't show up. So how does an AI data center actually get built? 4 things have to arrive in order. A signed power purchase agreement, meaning a utility has agreed to sell you electricity for the next 15 years at a price both sides can live with. A substation upgrade, meaning the local grid has been modified to handle the load. The transformer, and the chips. The chips are the only piece of that list that arrive in weeks. A power purchase agreement takes months to negotiate, and then years to generate actual power, because the power plant has to be built or expanded. A substation upgrade, under normal conditions, is 2 to 4 years. The transformer, historically, was 18 months. That was in 2019. In 2026, they don't look anything like that because everybody wants all of it at the same time. The hyperscalers are in line for transformers. So are the utilities replacing equipment that was installed during the Nixon administration. So are the automakers rebuilding plants for EV production. The electrified ports, the rail operators, the green steel projects, the battery factories. The pipe is finite, and the demand has all shown up at the same counter. So, of those 4 items, the PPA, the substation, the transformer, the chips, which one is actually running the schedule? The transformer, which is something you've probably never actually thought about if you don't work in power systems. Chips arrive fast. Money's been plentiful for 3 years and hasn't moved the needle. Labor is trainable, but transformer coil winders aren't. They're 5-year apprentices, and we'll get to that in a minute. The transformer is the piece with no substitute and no path to speed.
So let me take you there. What a large power transformer actually is a several hundred-ton, custom-engineered machine whose only job is to take electricity coming out of a power plant at, let's say, 22,000 volts, and step it up to transmission voltage, 500,000 or 765,000 volts, so the current can travel hundreds of miles along overhead wires without melting them. Every data center operating at gigawatt scale needs one of these. You can't swap it for something else. Solar panels don't avoid the transformer problem. Solar farms feed the grid through transformers. Nuclear doesn't avoid it. Gas peaker plants don't avoid it. Every piece of the energy system passes through one of these machines. Here is how you make one. Inside the transformer are two sets of copper windings, a high voltage winding and a low voltage winding, wrapped around an iron core. The copper isn't machine wound, it's wound by hand, by people, because the tension and the layering have to be custom to the specific voltage and power rating. And a machine that could make every voltage class would cost more than a factory full of people. A single winding on a 500 kilovolt transformer contains miles of copper strip, carefully stacked and insulated. And one mistake at any layer means you scrap the entire coil and start over. The bushings, the long porcelain columns that come out of the top of the transformer and carry the high voltage current into the air, require 18 months of dielectric conditioning before they can be installed. That's not a delivery time, that's a physical process. The porcelain and the paper insulation inside have to absorb oil, release moisture, and reach a specific electrical quietude that nobody has figured out how to speed up. You can't run a hairdryer on it, it has to sit. The core is made of individual steel sheets called laminations, stacked one at a time by a person with a pair of tongs. Stack them wrong, you get hot spots and eddy currents. The transformer overheats in service, and you have a $100 million paperweight. 50,000 sheets per transformer, stacked by hand. That's what's inside the transformer. Who makes them? If we're talking about the class an AI hyperscaler needs, 500 kilovolt and up, there are essentially 3 companies on Earth that make them in quantity. Hitachi Energy, which used to be ABB, Siemens Energy, which got spun out of Siemens in 2020, GE Vernova, which got spun out of GE in 2024. Between them, they build in the low hundreds of these per year, globally. Not thousands, low hundreds. Lead times in 2019 were around 18 months. Lead times right now, I checked, are 58 to 72 months. Which means if you place an order today, your transformer shows up sometime in 2030 or 2031. And you can't buy your way in. These 3 companies are running at maximum capacity. They will all tell you on earnings calls, in interviews, in trade publications, that they're expanding. Hitachi's bringing new US capacity online. Siemens is adding lines in Germany and North Carolina. GE Vernova has expansions in the pipeline. Those are all real, but they're also already pre-sold for the first 2 or 3 years of output. Here is the part I didn't know until I actually started reading about this industry. The United States used to make transformers. In the 1980s, we had roughly 7 domestic plants turning out large power units. By 2005, we had 1. The institutional knowledge, how to wind a coil at 500 kilovolts, how to stack a core to the tolerances the grid requires, took 20 years to train into a person, and most of those people retired during the offshoring decade. We're now rebuilding the capability at the pace copper can be cured. That's why a new US factory takes 4 years to come online, and still only opens fully in 2028. You can't just hire electrical engineers and go. You have to hire electrical engineers and then wait for them to spend 5 years working next to someone who already knows. So, 3 global suppliers, a 5-year wait, no way to accelerate. Here's the part that breaks the financial framing. The industry will tell you that capital fixes this, that if the hyperscalers commit enough money, the factories will expand, the supply chain will deepen, the whole thing will smooth out.
And that's not wrong on a 10-year view. Over 10 years, with enough capital, we'll probably double transformer capacity. But the AI build-out is being spec'd for the next 4. And on a 4-year view, you can sign every contract in the world, and the bushing cure is still 18 months. Capital doesn't compress chemistry.
The gas turbine has the same problem.
GE Vernova's large turbine order book is sold through 2029. The grid interconnect queue has the same problem. Most US markets run 2 to 3 years of studies before a new large load can even connect. These are real, but the transformer is the object that makes the whole argument impossible to talk yourself out of. You can subsidize a turbine. You can sue an ISO to jump the queue. You can prepay a contractor. You can't make a transformer appear. It's the one piece in this whole argument you can't negotiate around. It doesn't care what you're willing to pay, and it won't come out of a factory any faster because you wanted it to. That's what's different this time.
That's why half the 2026 announced US data centers are already gone. Not from bankruptcy, not from a funding gap. The buildings just can't be delivered on the announced schedule. This is where the finance framing and the engineering framing diverge. And I say this as someone who read the finance framing for about 2 years and thought it was enough. For 2 years, the question everyone was asking was, is AI a bubble? And the answers came back in the finance language. CapEx ratios, hyperscaler balance sheets, concentration risk, revenue multiples, the history of Cisco in 2000, the history of oil in 1979. I read all of them. I went on the same podcasts. I watched the same charts. The entire conversation was about the wrong thing. It wasn't a bubble question. It was a manufacturing question. The transformer doesn't care about the forward PE of Microsoft. It takes 5 years to build. That number isn't elastic. It doesn't matter how much money gets committed. It doesn't matter what the CEO says on the call. It doesn't matter whether the market believes or doesn't believe. The transformer sits in Varennes, slowly. There are 2 clocks running. One is press release time, where a commitment gets announced on Tuesday morning, and the stock moves by Tuesday afternoon, and by Thursday somebody writes a Substack about it. The other is electrical equipment time, where the object that has to actually do the work of the announcement was ordered 18 months before the press release and won't arrive for 48 months after it. We kept watching one clock and mistaking it for the other. Once you see the transformer as the axis, every AI announcement starts to become legible. Not all of them are real. Not all of them were ever going to be real. And you can tell the difference. So here's the takeaway. You can ask one question of any AI announcement you encounter from this day forward, and it will tell you more than every earnings call breakdown you've read this year combined. Where is the transformer, and when does it ship? That's the entire diagnostic. Every other thing you see in the press release, the gigawatt number, the state tax incentive, the photo of the CEO in a hard hat, the quote about supporting American innovation, is downstream of that one fact. If there's a transformer on order, the project is real. If there isn't, the project is a press release. How do you actually find out the answer? The press release itself almost never tells you, because transformer orders aren't a story. But you can triangulate. Start with the paired energy announcement. If the data center announcement has a named utility, a signed PPA, or a corresponding power plant being built, the project is plausible. If the announcement is just Meta is building, with no utility attached and no PPA referenced, the project is speculative at best. Next, the FERC. Since order number 2023, which FERC issued in 2023, and which took effect over the last 2 years, interconnect queue data for every US grid operator is public. You can look up any large load application and see where it sits in the study, when it's expected to energize, and whether the interconnect study has returned, here is what the grid upgrade will cost, and here is who has to pay for it. If the operational date in the queue is 2032, but the company's press release says opening 2027, the press release is the fiction. Third, the industry signals.
Hitachi Energy, Siemens Energy, and GE Vernova report on their order books in quarterly earnings. If hyperscaler transformer orders are rising, those three companies' backlogs rise. And the specific projects usually surface in trade publications: RigZone, RTO Insider, Transformer Magazine, within weeks of the orders being placed. The financial press doesn't cover transformers. The trade press does. And there's the part that almost nobody mentions: your electricity bill. When a data center connects to your local grid, the cost of the substation upgrade and the transformer doesn't vanish. Someone pays for it. In most US states, some portion of those upgrade costs enter the rate base, approved by your local Public Utility Commission, which means that if you live in a state with active data center development, you're quietly funding the AI build-out, whether you ever open the large language model on your laptop or not. Call it a pass-through. If you live near an announced data center, and more of you do than you'd guess, you've probably got a story about the rate hearing, or the press release, or the weird silence after a year of groundbreaking photos. I'd want to know what it actually looks like on the ground. The AI future isn't going to arrive the way the earnings calls described it. It will arrive unevenly, at the pace copper can be cured, at the pace factories in Quebec and Missouri can turn out their next 100 units. About a third of what was announced will get built on schedule. About another third will arrive late. And about a third will quietly never get built at all. Most people are going to experience this as a slow-motion surprise. A new data center that never opens in their county. An electricity bill that climbs for reasons that don't make sense. A promised AI job market that stays theoretical. Nobody is going to connect those dots for them. The story happens in factories most people will never see, on lead times they've never heard of, measured by a single object that almost nobody can name. The answer to where the AI boom went is a 500-ton machine in Quebec. And this is the third frame on the same story, the software side. The SaaS collapse, the seat compression, we covered in the episode on the software industry. The economic side, the shift of value from wages to capital, we covered in Ghost GDP. This is the physical side, and it turns out to be the binding one. If you want the software side, how AI is eating the industry that was supposed to ride the very build-out we just walked through, the software industry collapsing episode is on the screen right now. Watch that next.